ratios, we're going to find a side length. We want to continue to use the mnemonic SOHCAHTOA. So in this case, we're given EFG, right triangle, and we know that 9 is the hypotenuse and 63 is going to be opposite of EF, which is what we're trying to find. So I know that I'm going to be using sine. So here we go. I'm going to say sine of G equals EF over EG. So we know that angle G is equal to 63 degrees. We know that EG is equivalent to 9, and we're looking for EF. Okay, so when you're doing this, we're going to set this up, and you're going to take the inverse of the angle. So you're going to need to use a calculator. So it's going to be sine of 63 degrees equals EF divided by 9. So I want to solve for EF. That means that I'm going to multiply both sides by 9. So sine of 63 equals EF times 9, or divided by 9. So I multiply by the reciprocal of the denominator, which is going to be 9. So now I say that 9 is sine of 63 degrees, and that's equivalent to EF. And the reason why we can do this is because these 9s are going to simplify. So once I put this on my calculator, I know that EF is equivalent to approximately 8.019. And let's just say we round this to the tenths. That means that we're going to get approximately 8.0. And that'll be our solution for EF. Okay, I'm looking for RS, which is the hypotenuse. So in this case, I am going to use cosine. So let's talk about this. That means I have cosine of angle R is equivalent to RT divided by RS, because I'm looking for RS. And I'm given my adjacent side. So this is going to be the adjacent because it's next to the angle. So we know that R equals 23. We know that RT equals 7, and we're looking for RS, right? So when I bring this all together, I'm going to say that I have cosine of 23 is equivalent to 7 divided by RS. I need to go ahead and get RS on its own. So I'm going to cross multiply. This is another method of doing that if you're not comfortable with like multiplying by the reciprocals. So when I cross multiply, I'm going to cross multiply these two terms with these two terms. So I'm going to get RS cosine 23 degrees, all of this is in degrees, is equivalent to 1 times 7, which is 7. So I need to get RS by itself, so I'm going to say RS times cosine of 23 degrees equals 7. I'm going to divide both sides by cosine of 23 degrees. All right, so then RS is equivalent to 7 divided by cosine of 23 degrees. And then when I put this in the calculator in degree mode, I say RS is equivalent to 7.604. And I know the IXL is asking for the tenths. place. So when I estimate this, it's going to be 7.6. And that's my solution. I'm looking for ST, so that's going to be the hypotenuse. So because I'm looking for the hypotenuse, I'm going to use sine or cosine. I'm given the side across from 50, so I'm going to use sine. So that means I'm going to use, it's going to be sine of S is equivalent to RT, which is the opposite, divided by the hypotenuse ST. So RT is also the opposite. So I know that S equals 50. I know that RT equals 6. And I'm looking for ST. So as I set this up, I'm going to say, I'm going to work on the right-hand side. Sine of 50 is equivalent to, or 50 degrees, remember to be in degree mode, is equivalent to 6 divided by ST. So I'm going to put the sine over 1 and I'm going to cross multiply. So when I cross multiply, I'm going to get ST times sine of 50 degrees and then 1 times 6. So it's going to be ST times sine of 50 degrees equals 6. I want to divide sine of 50 degrees by both sides so I can get ST on its own. So that's sine of 50 degrees divided by sine of 50 degrees. So that's ST equals 6 over sine of 50 degrees. And you're going to put this in a calculator. So I know that ST equals 7.83. And let's suppose I'm asking you to give your answer in the tenths. So it's going to be approximately 7.8 is the length of ST. This is going to be a different example. In this one, we're asking you to find HI, and that is going to be the opposite side of what's given. So we have the adjacent, and then we have the angle, J, and then I'm looking for the opposite side from the angle. So that means I'm going to use tangent of J to equal HI over IJ. Okay, so that means that angle J is equivalent to 52 degrees, and that means that IJ is equivalent to the square root of 29. So when I substitute, here's what I get. I get the tangent of 52 degrees is equivalent to the HI divided by the square root of 29. I still want to go ahead and cross multiply. So when I cross multiply, I'm going to put tangent over 1. So here's what it's going to look like. I'm just going to use a different color altogether because I'm going to get confused. So that means that all of this is going to get multiplied, and then the HI times 1 is going to get multiplied because that's what we're looking for. So that's going to be the square root of 29 times a tangent of 52 degrees equivalent to HI, because HI times 1 is just HI. And then when I use a calculator, I'm going to get approximately, HI will be equivalent to 6.89. And then you want to do the nearest tenth for your answer. So that means that HI is 6.9. look for tangent again. So we're asking you to find Vx. Let's just change the color. So Vx is what we're looking for. Now this is across from 65, so it's opposite of 65, and then the adjacent is going to be square root of 13, so this is going to be the adjacent. So here's what I know. I know that I'm going to find tangent of angle W, which is going to be equivalent to Vx divided by Wx. W equals 65 degrees, and Wx is equivalent to square root of 13. So when I set this up, I'm going to get tangent of 65 degrees equals Vx divided by the square root of 13. I'm going to cross multiply. So that means that square root of 13 and tangent of 65 go together, and 1 times Vx is going to go together. So then I get square root of 13 times a tangent of 65 degrees is equivalent to Vx. I solve all this in the calculator. So that means that Vx equals, as a decimal, 7.73, and I'm going to round this to the tenths place. So I get 7.7 approximately equal to Vx.